students, greetings to you all. Hope you all are safe and doing good by God's grace. So, let's move on to the motivational quote for the week. Yes. So, success is the sum of small efforts repeated day in and day out. Yes, my dear students, the harder you work for something which you need to get it, the greater you feel when you achieve it. With this quote, we'll quickly move on to the recap session. Yes, in last class we started with new unit, which is nothing but the unit 11, atomic structure. So in this video we are going to continue with that. So in last class we started with atomic model, right? We saw two atomic model. One is the Rutherford atomic model and Bohr's atomic model. I hope everyone would have started doing your model as well. So please quickly do your model and submit it before this weekend. Okay, students? Yes. So topics to be concentrated in this session are discovery of neutrons, atomic number and mass number, electronic configuration of atoms, and valence electrons. So these four topics will be covering in today's session. So let's quickly move on to class. So in last class we saw two atomic model. One is the Rutherford atomic model and other one is Bohr atomic model. So according to Bohr atomic model, the entire mass of an atom was concentrated in the nucleus. So this is the nucleus, right? Yes. So because the mass of electron is negligible as compared to the mass of proton. So the entire mass of the atom is present inside the nucleus as the proton is present inside the nucleus of an atom. So scientists took two nuclei, okay, a hydrogen nuclei and a helium nuclei. We know that hydrogen has only one proton and helium has two protons. Then what would be the mass of it? The mass of helium should be 2 times of mass of hydrogen, right? As helium has 2 protons, whereas hydrogen has 1 proton. But when experiments were performed, scientists has observed that mass of helium is equal to 4 times of hydrogen. Okay, so where were the extra mass coming from the helium atom? Scientists concluded that there must be extra particle present in the nucleus of helium atom. This extra particle is giving the extra mass of the helium nucleus, and this extra particle should be neutral because an atom is electrically neutral. The number of electron is equal to number of protons. So now if the extra particle has some charge in it, it will make the atom unstable. So the extra particle should be electrically neutral. In 1932, a scientist named James Chadwick was very curious to know where was the extra mass in the helium nucleus coming from. So he performed many experiments, and in one such experiment he used beryllium nucleus and alpha particle. When he projected alpha particle on a beryllium, he observed a particle was released. Okay, and he called it as neutron. And now he wanted to check whether neutron is neutral or not. After experimenting it, he concluded that neutron is neutral in nature. It has no charge in it. And later, by further experiment, it was shown that mass of proton is equal to mass of neutron. Thus, the helium nucleus is 4 times the mass of hydrogen nucleus. Therefore, helium nucleus has 2 extra neutrons. These neutrons make the mass of helium nucleus 4 times the mass of hydrogen. Thus, this is how neutrons were discovered. So, neutrons is denoted by N01. Okay. Yes, the superscript 1 represents its mass, whereas the subscript 0 represents its electric charge. Let's move on to the properties of neutron. it has two properties. The first property is this particle was not found to be deflected by any magnetic or electric field, proving that it is electrically neutral. The second property would be its mass is equal to 1.676 into 10 power minus 24 gram, which is nothing but 1 atomic mass units. So at present, the nucleus contains protons and neutrons, right? And the electrons revolve around the nucleus in definite orbits. So this is the structure of an atom. The atom is built up of subatomic particles. So what are the subatomic particles? The subatomic particles are proton, neutron and electron. And there are two structural parts of an atom. One is the nucleus, which is at the center, and the empty space in which there are imaginary parts called the orbits. So these two are the structural parts of an atom. As we already knew that hydrogen has only one proton and helium has two protons, thus these number of protons in the nucleus decides which element it is. Okay, this important number is said to be atomic number of an atom. So this atomic number can be denoted as the letter Z, and thus atomic number is nothing but number of protons, which is nothing but is equal to number of electrons. And we saw that not only protons make the total mass of an atom, the neutrons in the nucleus also contribute to the total mass. As a proton and a neutron have the same mass, the mass of the particular atom depends on the total number of protons and neutrons present. This number is called as mass number, and it can be denoted as letter A. And mass number is nothing but number of protons plus number of neutrons. For any element, the atomic number is shown as subscript and mass number is shown as superscript. To represent an element, it is denoted as this. The atomic number is shown as subscript and the mass number is shown as in superscript. As we know that mass number is denoted as A and atomic number is denoted as Z. And X is nothing but the element. For example, let us take the nitrogen element. Okay, nitrogen element. So here it is 14 and 7. So what is the mass number and atomic number? Yes, so mass number, which is 14, and atomic number, which is 7. The difference between the mass number of an element and its atomic number gives the number of neutrons present in one atom of an element. So therefore, to get number of neutrons present, we can easily find it with mass number minus atomic number. For example, let us take aluminum element. So here, to get number of neutrons, we need to subtract mass number minus atomic number. So here, what is the mass number and atomic number? Mass number is 27 and atomic number is 13. Remember, mass number is always in superscript. Atomic number is always in subscript. Okay. So to get number of neutrons, we just need to subtract mass number minus atomic number. So 27 minus 13, which gives 14. So the number of neutrons present in aluminum element is 14. Hope it's clear to you. So now let us solve one problem related to it. The question is, calculate the atomic number of an element whose mass number is 39 and number of neutrons is 20. Also find the name of an element. So what we need to find? We need to calculate the atomic number of an element. Okay, they have given mass number and the number of neutrons present. So as we know that mass number is equal to atomic number plus neutrons. Yes. To get atomic number, we just need to rephrase this. To get atomic number, Atomic number is nothing but mass number minus number of neutrons. So when you substitute the values, you'll be getting 39 minus 20, which is 19. So when we look up in periodic table to find which element holds the atomic number as 19, it was potassium element having the atomic number 19. Good. Hope you understood atomic number, mass number and neutrons. Now we quickly move into electronic configuration of atoms. Okay. As we dealt in Bohr atomic model, the electrons occupy different energy levels called orbits or shells. So the distribution of electron in different shell is called as electronic configuration. This electronic configuration has certain rules or conditions known as Bohr and Bury rules of electronic configuration. So let's see the first rule. Rule 1. We saw that the shell which is closest to nucleus is the K shell and the next is L shell, M shell and so on. So the first rule states that the maximum number of electrons that can be accommodated in a shell is equal to 2n square. Here, n is nothing but the serial number of shell, where serial number is nothing but the K shell holds the serial number as 1, L shell holds the serial number as 2, M shell holds as 3. Okay, so here they have given shell KLMN, value of n which is nothing but 1, 2, 3 and 4, and the maximum number of electron in a shell is equal to 2n square according to rule 1. So 2 into 1 square gives 2, and for L shell 2 into 2 square gives 8, for M shell 2 into 3 square gives 18, and for N shell it is 2 into 4 square gives 32. So this is the rule 1. Let's move on to the rule 2. Rule 2 states that shells are filled in stepwise manner in the increasing order of energy. For example, in PT period, teacher make you to stand in height order to make sure that everyone is visible to her. Likewise, these shells are also filled in a stepwise manner in the increasing order of energy. Okay, in the increasing order of energy, it is being filled. Let's move to the rule 3. Rule 3 states that the outermost shell of an atom cannot have more than 8 electrons even if it has more capacity to accommodate electrons. For example, let us take an element calcium, okay, having 20 electrons. So it should be distributed as in the K shell, the maximum number of electrons it can hold is 2. 2 and the L shell 8 and the M shell 8 and the remaining electrons in is located in the N shell. As the rule 3 states, the outermost shell of an atom cannot have more than 8 electrons, okay, even if it has more capacity to accommodate electron. So this is how it can be distributed. So these are the 3 rules to be followed in representing electronic configuration. This configuration can be geometrically represented. For calcium, it can be geometrically represented as like this. So this is the nucleus, and the first shell, which is the K shell, holds the 2 electrons, and the second shell, which is the L shell, holds 8 electrons. You can count it 1, 2, 3, 4, 5, 6, 7 and 8. And the third shell, which is M shell, also holds the 8 electrons, and the last, the outermost shell, holds the remaining electron, which is 2. For let us take another example, an oxygen element. We know it has mass 16 and atomic number 8. Number of neutron would be atomic number minus mass number minus atomic number, which gives 8. So number of proton, which is 8, number of electrons also 8. So the electronic configuration would be 2, 6. So it can be geometrically represented as this. So this is the nucleus, and the first shell contains 2 electrons, and the outermost shell contains 6 electrons. So here we can see that there are 6 electrons in the outermost shell of oxygen atom. These 6 electrons are called as valence electrons. Okay, the outermost shell or it can be called as orbits. The outermost shell or orbit is called as valence shell, and the electrons present in the valence shell is called as valence electrons. So whenever the atom of an element contains 8 electrons in the valence shell, then that would be the most stable arrangement of an atom. So let us consider the noble gases. Okay, we know that the noble gases are helium, neon, argon, krypton, and xenon. So except helium, which has only 2 electrons, which is known as the duplet structure, and whereas all other elements which have 8 electrons in the valence shell is nothing but the outermost shell, has 8 electrons, which is the most stable arrangement of an atom. This arrangement is called as octet. All the noble gases except helium element, all other shows and obeys octet rule, whereas helium is the only noble gas which holds duplet structure. So whenever the elements which have 1, 2, 3 valence electrons, okay, valence electron, then it loses the electron in order to satisfy the octet rule. Such elements are known as metals. Whenever the elements which have 5, 6, 7 valence electron, then it gains the electrons in order to satisfy the octet rule. Such elements are known as nonmetals. If an valence electron has 4, then it can able to share the electrons, and those elements are known as metalloids. Elements having completely filled outermost shell show zero valency. Such elements are noble gases. Hope it is clear to you. So in this table I have given you the valence electron and the valency. For one valence electron, the valency you can written as +1, or you can just simply write it as 1 since it loses electron. Likewise, for 2 valence electron and 3 valence electron, the same procedure will be following. And for 4 valence electron, it shares the electron, therefore you can write the valence as 4. And for 5, it gains electron, therefore the valency can be written as -3, or it can be simply written as 3. Likewise for 6 and 7, -2 and -1 respectively. So let us solve one problem related to it. The question is, find the valency of magnesium and sulfur. Electronic configuration of magnesium is 2, 8, 2. So 2 is in first shell, which is K shell, 8 is in L shell, and the 2 is in M shell. So therefore the valency is 2, which is the outermost shell, which has 2 electrons. So the valency would be 2. Now let us consider the electronic configuration of sulfur, which has 2, 8, 6. So the outermost shell, which is the valence shell, has 6 valence electrons. So therefore the valency of sulfur is also 2. How it is 2? Because 8 minus 6, which gives 2. Hope you understood, students, and that's it for today's class. So let us quickly recap what we learned in today's class. We dealt with atomic number. So what is an atomic number? Nothing but number of protons, which is equal to number of electrons. What is mass number? How to calculate mass number? Number of protons plus number of neutrons give mass number. How to find out number of neutrons present in an atom? It is nothing but mass number minus atomic number gives the number of neutron. And to represent an element, it is denoted by XAZ. A is nothing but mass number and Z is atomic number. Be careful, students. A is nothing but a mass number. Don't think A is an atomic number. Okay. So A here it represents as mass number and Z as atomic number. And we saw valence shell and valence electron. So the outermost shell is called the valence shell, and the electrons present in the valence shell is called as valence electron. Very good. So for the follow-up work, I've given you the four problems. Okay. In this video also we saw a few problems. Related problems only I've given you here also. So try calculating it, take a picture of it and upload it in Google Classroom. Thank you so much, students. Stay home and stay safe. God bless you.